Plotting in the MATLAB is a wonderful experience. MATLAB has very powerful features for plot, and that can be demonstrated with this example. Here I am solving the problem of a beam vibration. This is my beam. It is a cantilever beam, fixed end and the free end, and I am applying a dynamic force here, and I want to visualize the tip displacement. So this is very first plot which I created using simple plot command. You can see that this is a displacement of the tip, but there is nothing on the y-axis, on the x-axis, the font size. So little mismatch what is available on the screen and what is written on the x and the y-axis. In the next figure, I have added caption on the y and the x-axis, displacement and the time. Simultaneously, I have increased the thickness of the line, and that has been done using the commands which we are going to learn in this lecture. In the next figure, I have changed the color of the line as well as I have added title of my figure. In the next figure, I have increased the size of my captions as well as the title caption. I have added this legend which is indicating that this red color line is tip displacement in meter. You can also find the grid lines in the figure. In this figure, I have increased the size of the numbers written on the x-axis and the y-axis. So if you will see your last figure and you will compare your last figure with your first figure, there's definitely a change in the quality of your figure. In this figure, I am just visualizing the displacement with respect to time. It is, you can see that this is a live displacement or the vibration of the beam, and it has been done using the for loop, which we are not going to learn in this session but in the future lesson. The same can be seen in opposite other fashion, that the top and the bottom side, top figure is indicating the beam vibration and the bottom figure is indicating the time versus displacement plot. So you can see that MATLAB has very good feature in which you can make your plot in a very efficient and fashionable way. In today's session, we are first going to learn how we can make a good plot using the command. At the same time, I will also show you that the same thing can be done by directly working on the figure file. For example, if this is my simple plot, I can change the thickness of the line directly. I can select my line, and by right click I can change the color of my line. I can change the style of my line, like I can change it as a dash line, or I can just change the thickness of my line, or I can add markers. Markers means you are going to add some points at the location of the data point. So you can see now that this is my line and I have added some markers. So when you will go and you will see it very closely, you will find that these are the markers created at the data position. So first I am writing CLC, that means I want to clean my command window. Then I am saying clear all, so I will remove everything from the workspace. And when you work with some figure files, writing close all is good, because close all will remove or close all the files. So in this case, you can see here that the three figure files are there. There is variables available in the workspace, as well as command window is also showing some output of the previous code. Let me run this code, which I have already saved as my plot1. When I will run this code, CLC will clean the command window, clear all will clean the workspace, and close all have already closed your all the figure files, so there is no figure file available. So for MATLAB, plot is the command. Using this plot command, you can simply plot any of the variable, and if you want to see the plot command in detail, we can simply write here that help plot, which will give us all the information related to the plot command. For example, here you can read that you can use the plot command to plot two variable x and y, or x and y both are the vectors, or you can simply use single vector and that will give you as an output of a plot command, or we can add many more things in the plot command. So I want to create a harmonic function, and then I want to visualize the plot of the harmonic function. For that, I am first creating the time, which is starting from the 0. There is an increment of 0.01 and it is reaching up to the value of 2. I am creating my harmonic function h1, which is 10 sine 2 pi, that's 4, and t. This is standard expression to write a harmonic function, where this 4 is indicating the frequency of my harmonic function, and the harmonic function will have the length from time t is equal to 0 to time t is equal to 2 seconds. If I will simply say the plot and the h1, it is going to show me the h1 plot without having the time on the x-axis. So here the y-axis is indicating the h1, but x-axis is having just data point, it is not the time. So we can see here that there are total 201 data. If I will add this time here, that means on the x-axis time will be shown, and on the y-axis the harmonic function h1 will be shown. You can check now that at the x-axis the time is starting from the 0 value ending at the 2 value, and y-axis is showing the value of h1. Suppose I want to increase the thickness, so I have a command line width, but it will be in the inverted comma, and I can say the thickness. I can define the thickness of my line. When I will run this, you can see now the thickness of the line has increased. Suppose I want to see the graph with a larger y-axis, so I can put the y limit. Y limit, I want to create the y limit between -20 to +20, so I can say -20 to 20, closing with the square bracket. This is standard command for the MATLAB, where you can set the y limit. Similarly, you can also set the x limit, but here my x limit is from 0 to 2. Suppose I want to create the x limit for -1 to 3 value. You can check now. So here is the output. You can see that my y limits are now +20 to -20, but my data is actually having the amplitude +10 to -10, so it is limited up to +10 to -10, and I have increased the x limit, which is from -1 to 3. So you can see here that the my length of the x-axis is from -1 to 3, but currently the x limit is not important, so I'm changing it into comment line, and for that what I'm doing, I'm just pressing one percentage symbol before the line, so the MATLAB will convert it into a comment line. And again I am plotting it. Now you can see that the y limit is 20 to -20, but x limit is still 0 to 2. If I want to give the x label, I can write x label, and value of the x label is, let's time in seconds. So this is the standard command to write the x label. Similarly, I can write the y label, which is displacement. Let's see now. X-axis is showing as time and y-axis is showing as displacement, but font size is small. So what I can write here, I can write font size. This is a standard command for the MATLAB, but here also we have to put some it is in the bracket, inverted bracket, and I can give the magnitude of my font size, let's 20. The same can be written for the second line, and now you see the font size has increased. This is the 2020 font size. I can also add the title of my figure. So to say, write the title, and I can say that this is, let's, displacement of a beam. So here the displacement of the beam is added at the top of your figure. Here also you can increase the font size. So I am adding this standard statement of the font size, but this time I want to increase the size up to 30. You can see now that the displacement of the beam is written at the top, and the font is really big now. I can add the grid, and to add the grid, what I need to write, I have to just say grid on. You can check now the grid is there in your figure. You can also plot two different variables simultaneously. For example, I am having another variable h2. This is my second variable, and there are different way to plot multiple variable on a single plot. The first method is just add the time and h2 in the same plot. So now I am having time versus h1 as well as time versus h2, and this is the output. You can see that now the red line and blue lines are available, but MATLAB has considered the color of the line by default, but you can see that the second is having the 20 value, so the red is representing the second one and the blue is representing the first one. But I can also differentiate this by adding the legend command. So I can add here that legend, and for data 1, data 2, you can check now. The legends are there in your figure. One is for the data 1, the red one is for the data 2, because this plot is sequentially taking the h1 as the first variable, h2 as the second variable. So data 1 will be corresponding to the first and data 2 is corresponding to the second value. Another method is that instead of writing the time and the h2 in the same figure, I can use the hold on command. This is really an important command, useful when you are trying to plot the data in a loop. When you are running a loop, let's 20 times, and every time you are creating some data, and that data has to be superimposed on the existing figure. That time you can use the hold on command. Otherwise, what will happen? Suppose I am writing another line plot, and that time I am saying that the time versus h2. When I will execute this, what MATLAB will do? MATLAB will remove the first figure and the second figure will be overlapped. You can check now that this is the output, and my output is having only second data. First data is not there because MATLAB has overlapped. But what I can do, I can use one hold on command, and then again I am running my code. Now what will happen? You can see now, because of the hold on command, both the data is there in my plot. Or what I can do, I can make two separate plot. To make the two separate plot, what I need to do, if I want to make two separate plot, I have to assign two figure. So this is my figure 1 and this is my figure 2. When you are writing this figure word, MATLAB is going to create a blank figure file, and then whatever plot command will be there, that plot will be available with the corresponding figure. So you can see now that there are two figures available. One is figure 1 and this is figure 2, but we can find the legend and all other things only in the figure 2, because for the figure 1 plot 1 there is nothing available. But what I can do, I can copy these three lines for my first figure, so that when I will plot now, the two figure will have X label, Y label and other things. But grid on is there only for the plot 2. So grid on and legend is available for the plot 2. But now I hope that you have understood, writing these command, you can improve the quality of your plot. The last part of the plot section is that how to measure the data directly on the plot. So for that purpose, I am making a second plot, but here in this case, I am increasing this limit so that we can clearly visualize the graph. And this is your second graph. And suppose you want to measure this value of this point. So what I need to do, I have to simply select this data cursor, and then when you will press the data cursor, it is going to give you the position or the value, the x values corresponding to x-axis and y values corresponding to the y-axis. So displacement is 20 at time 0.5 second. If I want to find the position of this point, you can check. If you want to keep the previous one and want to create another cursor, what you need to do, you have to press the Alt button, and then when you will select the second point, both the data point or cursor point will be available. In one, you can create multiple data point by pressing the Alt button. If I'll select this cursor point, then I can simply press forward or backward button to move the cursor from one position to another, and you can check that this can move and you can measure the different data point. Second thing, if you want to add some arrow or you want to add some text, here this text arrow feature is available. So putting this text arrow, MATLAB can create the arrow, as well as at the tail of this arrow you can write text. For example, I can say that this is my point things. If I want to increase the thickness of my line, I can again select the line. This is my line, and line style, I can increase the thickness of my line. I can change the color of my line, let red one or the brown one. and I can also add the markers. So these are the markers. The markers are indicating that these are the actual position where the data points are available. Remaining, it is just a curve fitting between these points.